We've talked about iterative methods for solving the Laplace equation, the Jacobi method, the Gauss-Seidel method, the SOR method, successive over relaxation. There's one more variation that I should mention, and I'll do that in this video. It's actually a picture that I chose as the icon of the course because I think it's a rather striking picture of a grid in the numerical method. That's called red-black ordering. If you forgive me, the purple color represents red, and the blue color will represent black. The idea of red-black ordering when you're solving the Laplace equation is that in the solution of the Jacobi method, say, the value of phi at this grid point here is updated using the value of phi at the one above and one below, and one to the right and one to the left. So the value of phi on the red grid points is updated using the value of phi on the blue grid points. And similarly, the value of phi on the blue grid points, or black here, in red-black ordering, the value of phi on the black grid points are updated using the values of phi on the red grid points. So that leads to kind of a way of doing the updating scheme. First, you update all the red grid points because you use the value of the black grid points at the previous iteration. They're all at the value of the black grid points are all at the same iteration step. Then you update the value of the black grid points, and you're using the value of the function on the red grid points then at the previous iteration. So first you update black, then you update red, then you update black, then you update red. If you use that type of iteration scheme, it will tend to converge a bit faster than if you just update everything at each iteration step. Okay? The computers have gotten fast enough that a simple problem such as the Laplace equation, it doesn't make any difference anymore. But these type of optimizations used to be very popular when the computers were much slower. Here, I think this is a nice lecture to add because I like the icon. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.